Looking up in the chat. Welcome to the ASME seminar, Metal Additive Manufacturing. What's in it for me? I'm Alan Brown, Senior Editor of ASME's Mechanical Engineering Magazine and today's moderator. Today, we will be talking about why the market is booming for engineers with additive skills and how you can be part of this fast-growing field. Our three speakers, and I'll introduce them in a moment, are going to talk about which companies are recruiting additive engineers, what they pay, what skills you need, and how to get those skills. But first, let's spend a couple of minutes talking about why additive manufacturing is becoming a real game changer. First, metal additive manufacturing is becoming a true production technology. The price of additive machines fell 20% in the past year alone, and these machines have build times that are getting faster and faster. Not only that, these machines can also make demanding parts, things like parts for jet engines and hip implants. More importantly, though, users have figured out how to make these economics work for them. I'll give you an example. Last month, General Motors showcased an additive stainless steel seat bracket that's 40% lighter and 20% stronger than the machine part it could replace. But the real benefit to General Motors is that this part consolidates 8 different parts that were made by several vendors into a single piece. GM expects to be making tens of thousands of parts like this at scale within 5 years. Other large companies are doing similar things. General Electric's new propeller engine consolidates 855 components, that's 855 different components, into just 12 parts, and it's going to eliminate 10 to 15 different vendors. Additive may cost more than conventional machining today, but the gap is narrowing, and additive parts consolidation saves money on a whole bunch of things, like assembly, shipping, warehousing, and managing giant supply chains. It also lets companies enter small niche markets without having to invest in expensive hard tooling, and it lets them make spare parts on the spot. It's a new way of doing business, and you can be part of it. To fill you in, we've invited some experts on additive jobs to this webinar. First up is Nick Pierce, founder and director of Alexander Daniels Global, a recruitment firm that specializes in additive manufacturing professionals. That's who they recruit, people for additive manufacturing. Nick's firm recently completed its second annual additive salary survey, and he's going to share some of his insights with us. Then comes Mile Miyamoto, additive manufacturing chief engineer at Boeing Commercial Airplanes. Boeing has more than 67,000 parts made by additive manufacturing that are currently flying, and it recently received FAA approval for the first additive structural part on a commercial jetliner. The company's leadership believes additive manufacturing is critical to future success, and Nile is leading the effort. And finally, we will bring on Tim Simpson, a pioneer in additive design at Penn State University. Tim founded the first graduate-level additive program in the United States and is co-director of the Center for Innovative Materials Processing through Direct Digital Deposition, one of the world's top additive engineering programs. Tim is also developing ASME's additive manufacturing courses, and we will tell you more about that later as well. So before we start, please remember that this is an interactive seminar. I'm sure you're going to have questions as you listen to our speakers, so please click the Q&A box and write them down. We will try to answer as many as we can during the discussion part of the webinar. So Nick, let's begin with you.
Thank you for that introduction. So briefly, as Al said, I'm the director and founder of Alexander Daniels Global. We specialize in identifying, engaging, and attracting talent to additive manufacturing. We started in this industry over 4 years ago because of a passion for the technology and specifically its application in medical. And we started with research. We understood the challenges the industry faced around speed, repeatability, cost and availability of materials. But what came through from speaking to the industry, that talent was the major problem. So we founded Alexander Daniels Global with a vision, and that was to enable the industrial revolution in additive manufacturing through talent. And it's through that we've come to further support the industry, and in doing that create the salary survey to answer the questions that we receive daily from our clients about what will it cost me to recruit an additive manufacturing engineer, and from candidates, what could I expect to earn if I join this industry. So let me just share with you a few of the stats. So currently, in terms of jobs, there's a big gap between the number of jobs in the market and the number of candidates in the market. One of the things that we found through the research that we've done is that specifically you've got a compound annual growth rate of additive manufacturing at roughly 27%, but the average annual growth rate of candidates is around 8%. And for engineering professionals, in particular with skills in additive, 8.8%. So what that says is that there are 3 times as many opportunities being created as there are new candidates being created within this industry. At the same time, what we see is that it's a very young industry. 41% of engineering professionals working in additive manufacturing have less than 5 years experience. So it's a market that's dominated by, relatively inexperienced professionals. So that means that, the need to bring new professionals in is ever growing. The value chain for additive manufacturing and opportunities is very wide. So we have the original equipment manufacturers, and there are lots of new entrants coming into that market. Initial players such as Stratasys, 3D Systems, and EOS are now finding competition coming in the wake of organizations like HP, Markforged, Desktop Metal, who are all very aggressively recruiting new staff. At the same time, we have an increase in contract manufacturing and service bureaus, with major industrial companies like Siemens, Oerlikon, Arconic entering the market and developing tailored solutions around materials and contract manufacturing to support organizations with the development of products. At the same time, the value chain also includes material companies, companies such as Henkel, BASF, Covestro, all of whom are now developing additive teams that require people. Software companies, Dassault Systems, ANSYS, Autodesk, very heavily investing in products that meet the demands of this industry. And we've touched upon the adopters of the technology: GE, BMW, Boeing, Airbus, all of whom are investing heavily in this. And this is creating demand. And where do we see demand within this industry? What type of roles do we see? So there's a big demand for professionals with experience in research and development, materials science, and applications engineering. So what are the sort of skills you need to do that? Well, design for additive manufacturing is critical. Material science knowledge, metallurgy. But I think what is unique about additive manufacturing is the fact that you need to have a wide breadth of knowledge across a variety of different skills. Just understanding material science isn't enough. You also need to understand a little bit about product design, a little bit about software, in order to be really successful in creating a great product or a new application within additive manufacturing. We're seeing salaries for additive manufacturing increasing significantly. So For people working in research and development, we saw an average salary increase of 24% for people with 0 to 10 years experience. One of the most significant statistics that I would point out is the difference between somebody with less than 2 years experience and somebody with 2 to 5 years experience. This is where we saw the greatest growth in salary. So on average, professionals working in R&D with less than 2 years experience in additive manufacturing could command a salary of about $62,000 in the US. Add another couple of years experience in, so somebody with 2 to 5 years experience in additive manufacturing working in R&D could command an average salary of $100,000. So that extra experience gain sees a significant growth in income. What does this mean for individuals? Well, a career in additive manufacturing is a career that's going to see you be able to augment your salary and increase your opportunities to progress your career where there are an increasing number of opportunities. And just projecting what that might look like, what we wanted to show by this slide is how you might see salaries increasing over the next 5 years within the industry. So somebody just about to join the industry, thinking about a career in additive manufacturing, if you've got just a few years experience under your belt within this industry, you can see over the next few years how that's going to increase your earning potential. So that's it from me briefly on the jobs market. I'm sure if you have any questions, we can answer them as the seminar goes on.
All right. This is Naomi Miyamoto from Boeing. And maybe I'll just start a little bit here with a little background about Boeing and additive manufacturing. We've been involved in additive for over 20 years now, starting with stereolithography way back. I remember having these big yellow expensive models that we were printing, but we've come a long way in that time, and I think the industry is really taking off today with the new technologies becoming available. But we've had airplane parts flying using 3D printed different technologies for about the last 15 years, and we've got more than 60,000 parts today in both our commercial and defense products. Those cover a broad range of parts from satellites to fighter aircraft and commercial airplanes, where we've got a lot of polymer printed parts today. We even have parts that are moving forward for the new commercial crew capsule that we're doing with NASA. And in 2017, we installed the first additively manufactured titanium structural part that's FAA qualified, and I'll show you a picture of that on the next page. We've also got sites all over the world that have 3D printing capabilities, including Europe, Australia, Canada, and a lot here in the United States. And for a little while, we held the world record for the largest 3D printed item, which is a tool created for our 777 program. And it was over 1,600 pounds, and I believe it took several weeks to print that part out of a large polymer material system that we worked together with Oak Ridge National Labs. This here on the left is a picture of that titanium structural part. It's called the galley support fitting. It's installed on every 787 we deliver today, and it was produced using a wire feed process out of titanium. And what it does is it improves what we call our buy to fly. It's how much material we have to buy versus how much actually flies away. And using the additive manufacturing process, we're able to put material just in the right places and allow the machining to be reduced and produce a part for a lower cost. And then over on the right is a part using a titanium powder bed process. It's a snubber, we call it the snubber fitting. It's installed in the aft part of a 777 aircraft, and it holds the auxiliary power unit, goes up in this big compartment there, and there's an maintenance access panel or big door that you can kind of see there. And this part is installed to help hold the door open, and it replaces a traditionally machined part that is normally installed. And this was flown on our Eco Demonstrator program recently using a 777 and applying about 30 new technologies to that aircraft that we partnered with FedEx to put into a flight test program. And the part is saves weight, and it also cut the number of fasteners required to install it by more than 50%. And we used a kind of a topology optimization tool to design that. And so just to give you an idea of what we're looking for within Boeing, I pulled a current job opening we have right now. It's posted on our website, and these are for actual additive design engineers. And you can see we've kind of broken this up into required qualifications and preferred qualifications. So as a basic requirement, we're looking for someone in this case with some design for additive experience. They need a degree in mechanical, aero, or civil. And because of our process internal to Boeing, we look for those with an ABET accredited university degree and some proficiency in a CAD system. We use CATIA V5 internally here in Boeing Commercial, but other divisions within Boeing currently use NX and other software, so we're not too particular about that, but some sort of CAD proficiency is required. And then as a preferred qualification, things like a master's degree or experience with the actual machines in terms of parameter development, process controls, simulation software. If you're familiar with topology optimization software, that's a plus. Any kind of hands-on experience. It could also be with subtractive manufacturing, also with polymers or composites. Those type of experiences translate really well. And also manufacturing processes. I have a personal interest in biomimicry, and I think that's a great skill. It's hard to find, but that's another good skill to have, as well as just aerospace design and test experience. And we have just kind of a basic, what we're always looking for at Boeing is people with a passion for the aviation industry. It could be commercial, could be on our defense side, but really just somebody who comes in and is really interested in the area that we work in. Also looking for good communication skills, as well as being able to work in a very collaborative team environment, and looking for those with, obviously, like most companies, someone who's motivated and able to execute tasks under a very challenging environment at times. And so if you're actually interested, there are some postings you can visit our website, and I'll leave it at that.
Okay, very good. And now let's hear from Tim Simpson.
Thank you very much. So Tim Simpson here. As I said, I'm at Penn State University. Actually, background is all mechanical engineering and industrial engineering, but been sort of a user of 3D printing for many years, but now, particularly the last 5 or 6, as co-director on our center, doing a deep dive into the materials and the processes, so that at the end of the day, figuring out exactly what it is we need to train our next generation of engineers in, and also the current engineers that are out there. What do they need to learn relative to additive manufacturing to be able to use it effectively? So 2 slides. One, the other hat that I wear is I'm now director of what we think is the first and only additive manufacturing and design graduate program that's out there. This was actually launched a year and a half ago now. So figures and statistics here that have sort of helped fuel this. There was actually a team effort across 5 different departments. Be able to pull this together. Obviously, depending on the projections, Wohlers report or others, we're going to be, the industry will be at 20 billion, 40 billion. I've seen upwards of 450 million billion over the next couple of years. But the compound annual growth rate there is pretty high, regardless of what those numbers are. We've also seen, consistent with what the others are saying here, significant increases in interest in terms of 3D printing job ads. 3D printing industry now actually runs its own 3D printing job board, and you're seeing these continue to pick up. And IEEE did a study, I think 2 or 3 years ago now, where 35% of all engineering jobs had 3D printing or additive manufacturing as one of the must-haves or nice-to-haves in their job description. And I mean, if you look around, there aren't any actually dedicated programs on this. You certainly have, most universities have an introduction to additive manufacturing course of some sort, where you learn about the processes, maybe you do a little bit of the design work for additive. But we actually, across mechanical, industrial, material science, engineering design, and engineering science, got together and created a brand new degree, both an MS and an MEng, Master of Engineering, and a Master of Science, that you can get either online or in resident, where we deep dive into the processes as one of your courses. So what are the different 7 processes? The materials for additives, so taking a look both at the metals and polymers as well as ceramics, and getting down into process structure property relationships among them. Design for additive. End of the day, anybody can buy a machine and learn how to turn it on and fill it with powder and hit go. But if you don't know how to design your parts and products for additive, then you got a very expensive paperweight there for you. And then also the science of additive, as we're learning more and more about the physics of what's going on, laser powder interactions, sensing, monitoring, those sort of things, distortion, thermomechanical, et cetera. How does that all influence, new processes, new materials, new design methods, new software and tools to be able to do that. We have a hands-on lab that we offer as well, where we're designing and redesigning and optimizing parts for metal additive, and then actually building and testing those. And then if you want to go out for the full degree, a couple of electives, do a project and a seminar, and voila, you've got a master's in additive manufacturing and design. We've actually, since we launched, we've been getting 12 to 15 applicants per semester. We're up to 40 students already online. We're bringing in our first class of resident students, 12 students this fall. So within a short time frame, we're already well over 50 students in the program, and interest continues to grow because, even students, as was said there, even if you've only been out 1 or 2 years, you may have missed this courses, the opportunities. And so companies like GE and Boeing and Lockheed and Siemens and software folks and the carpenters, materials providers, everybody is spooling up, ramping up, and everybody needs to know all aspects of the various processes and the materials and everything associated with additive. So just a quick, into my next slide there, just a quick plug or thought. As a design guy, one of the things that's leading me to work with ASME here and on the course that we're putting together within their learning and development group is the existing engineer who's been out of school a couple of years, has missed the wave, and is trying to figure out, all right, what do I need to know? How do I learn about additive? And again, how do I design for additive? And so as part of my role, we work with a variety of companies and help them doing research projects, understanding the tool workflow and the software that's available out there. And we sort of see 3 companies going through 3 stages when trying to adopt or move into additive manufacturing. I sort of call these my crawl, walk, run when it comes to additive manufacturing. They start off that first use case where they're essentially replicating an existing part with additive. Essentially, they go through, screen a bunch of parts and say, hey, this looks like a good candidate. Let's see, how does it compare or perform if we additively manufacture it versus machining or casting. Next case then is we start adapting for additive manufacturing, where we can essentially start tweaking some of the geometries or features to try and improve it. And then the third one is optimizing for additive, where we can really take full advantage of the benefits that additive manufacturing allows for us. And as we move through and progress through those 3, we get more and more experience, and we actually can accrue more and more benefits, deal less and less with the restrictive aspects of the process, and take more advantage of the opportunistic aspects of additive manufacturing. Thank you, Ellen.
Okay, great. Now we can start the fun part, which are the questions. We've got a bunch of audience questions, and I have a few of my own. So let me start with one of mine. So let's say I'm a mechanical engineer with several years of experience designing parts on a CAD system. Shouldn't additive manufacturing be a breeze for someone like me? What do I really need to know that I don't know now? And that's for all of you. Niall, why don't we start with you?
Sure, I can start. I think you certainly would come in with a lot of experience. I think one of the differences is really shifting your mindset from what we traditionally use as a subtractive manufacturing processes with machining and other things like that, to really an additive process. And what we're finding is the capability of the machine really opens the design space and allows you to look at a design differently and think about different ways of manufacturing that you just couldn't do with a cutting tool or a drill bit. And so those are some of the differences, I think, that come about. It's something that is learnable and definitely something that could be picked up pretty quickly, actually.
Tim?
Sorry.
Oh, go ahead. Nick, go ahead.
Nick here. Yeah, I could add something in that. I was speaking to a large engineering company who have looked at how they retrain their existing design engineers, for example, to meet the requirements of additive. And the biggest challenge that they face is shifting the perception of the individual about what is possible. And I think that's probably the biggest thing that an experienced engineer like the individual that you sort of referenced there, Alan, needs to do is sort of, shift their mindset from what they know now as being possible to what could be possible, and adopting a much more creative approach. And this is one of the key skills that maybe wasn't highlighted in my presentation that goes beyond the hard skill that you can sort of assess for. And creativity, I would suggest, is very, very high on the list of skills that organizations look for when recruiting candidates in a role for additive manufacturing.
I imagine, just to interject, Tim, before I turn the question to you, I remember looking at Niles's piece, the piece he showed, the revised piece, and I mean, I know what a bracket looks like, and this doesn't look like a bracket. This looks like it came off somebody's model of a Borg starship from Star Wars, right? It's organic, it flows. It doesn't look like a real bracket. I know. I imagine people have a lot of trouble with that sometimes. But Tim, I wanted to get your take on that question. What do engineers need to know?
No, I think you're sort of hitting the nail on the head there in a sense. We're used to designing in XYZ, extrude, sweep, revolve, sort of our CAD tools that we grow up on, and yet here we have an opportunity to literally put material at any point in any position in 3D space that we want to, so our brackets don't need to look like brackets anymore. We truly get to optimize those, and that takes, it's an opportunity for creativity there beyond what we're used to doing. Certainly as engineers, I think I see many studies where engineers become less and less creative the longer that they're in school, which does not bode well for us, but this is a chance to really be creative and think differently and outside the box, and we need to be able to do that.
Excellent. I know, Niall, Boeing has a good-sized program to train engineers in those kind of skills, doesn't it?
Yes, we have quite a bit of internal training.
I'm curious. Go ahead.
Oh, I was going to add that I think, but partnering with folks like Tim and other universities is really where we're trying to expand that, just to get more of our engineers involved as well. So there's some internal training, but we're also really looking at external universities and other organizations like ASME to help us with that.
Yeah, and one question I was going to ask you about your training. Is this something that everybody succeeds in, or are there some engineers that just don't get it?
I think you're hitting on something there. Not every engineer comes in and is really. It's hard for them to open for some of them to open their minds up to, as Tim was describing, this you can put any material anywhere you want in 3D space. And we're finding that some of them take to it much easier, and others tend to struggle a little bit with it. We're finding a lot of folks that are joining our team that have their own printers at home and have been doing this for maybe a year or more, and are out there experimenting, making parts. One of the guys is making parts for his car on the weekends, and so those folks, I think, adapt a little better. But it's certainly the folks that are really interested and have a passion for it is what we're looking for.
Alan, if I can. No,
Go
if
ahead.
if I could jump in here real quick, we've actually just been running. We've got a grant from National Science Foundation looking at how do we teach creativity for additive manufacturing, and so we've started doing studies both with freshmen and more seasoned, juniors and seniors. So, what do you know coming in as a first-year student? You may have had exposure to CAD or a 3D printer in high school versus, you're getting ready to graduate with an engineering degree, and how do you sort of approach the problem? And to your point, I think one of the things we found it's much easier to train the restrictive aspects, sort of what the process can or can't do. You can't have very thin walls. You got to deal with overhangs. If it's too thick or too chunky, or how to orient support structures. So we're used to as engineers, and designers, used to thinking about the restrictive aspects of a manufacturing process, and studies show that we can teach those, and those are easy for students to pick up. But it's really the challenging part is you need the right mindset, the right mentality to really take full advantage of the opportunistic or the beneficial aspects. So the bio-inspired designs, when to use a lattice structure, generative tools like topology optimization. Those things are certainly that's where a lot of the hype and excitement is around additive, but that's also, it turns out, one of the things that's much more challenging or difficult to teach that we're seeing so far.
Yeah, Niall, I want you to answer a slightly different question, but it's related to this.
Okay.
What about engineers who don't have a formal training, but they do have their printer? They have their 3D printers at home. I've met several people actually who make car parts. Or they're in school and they've done competitions where they've built parts, but they don't really have a formal training. Or they're makers and they don't even have an engineering degree. Could a maker jump to a corporate job?
Well, one of the areas we do hire in our technical workforce, we have positions that we are starting to look at for drafting positions, so drafters, like an associate's degree and those kind of positions. So you don't have to have your 4-year traditional engineering degree, and we're really looking at that because, as you say, this space is really opening up, and I think we're going to have to be more open to some non-traditional skilled folks who are in that maker space and other areas like that. So we are actually starting to discuss how we will attract and hire some of those folks as well. But as you kind of saw in our job opening, more of the jobs there are around the traditional 4-year or Masters of Engineering kind of degrees. But I think the industry is going to really have to shift, as you point out.
Nick, what about you? Or when you talk to companies, are they open to hiring people without engineering degrees or people who have informal training?
I think it's a challenging one. I think in the larger corporates, there are certain organizational structures in place that prevent hiring at a certain level without degree or higher, which limits the opportunity for the maker community, the passionate enthusiasts, to access those type of opportunities. I think what we're starting to see more, however, is a loosening of those requirements within organizations as the skills gap starts to widen and the need for talent increases. And I think it's really important that organizations do understand the value that somebody without the academic qualification but with the passion and understanding for the technology can bring to their organization. And in fact, perhaps one area where we do see this more than others is with service engineers, for example, in the leading 3D printer OEMs. In fact, they're a little bit more relaxed on recruiting people with a PhD or a master's. And in fact, we've got one client who looks for, in their words, the tinkerer, the guy who is building car parts in his garage, who really gets this technology and knows how to fix stuff. And as a service engineer, that's really what you're doing. You're helping to install the machines, you're providing training and support to new users, but also you're solving the problems. And sometimes having an academic qualification doesn't teach you how to solve a problem with a printer. It's more the fact that you just know how to fix stuff. And I think that's one area where there is a big opportunity to access the industry. And once you're in, it's more easy to progress within it.
So we have a question from one of our listeners. And, you know, this is a person with skills in product design, DFAM, topology optimization, CFD, and things like that. But how much material knowledge do they really need? Do they really need to know materials, or is that just a Boeing thing? You want to take a shot at that, Niall?
Sure. Materials is helpful, and because we are really dependent on the different material systems and the, in some cases, the chemistry and the makeup of the materials, the behavior of the materials, it certainly is helpful, but it's not, as we put it in our openings, it's not a requirement. But having some material knowledge is definitely a plus in terms of when we're looking for someone. But in the case of a design engineer, really having the design experience is more important. But as we look at the complexity of the different additive technologies, it is very helpful to have some materials background and experience.
Nick, does that come up much for you? Materials?
Yeah, and I think material science of all of the skills that we see in demand is probably the highest. Because it's something that is required by almost all of the stakeholders within the value chain. I think if you're in a design role, understanding how the material will react given the process is important. And as I sort of outlined in my presentation, you know, additive is, you know, a mixture of materials, hardware, software, design, and actually you probably need to, as I said in the presentation, have at least a basic understanding of all aspects. While you might major in one, having a basic understanding of all aspects is ultimately what will deliver a successful part or a successful application.
Yeah. You know, it's interesting. I was just thinking now about your wish list for Boeing, what you'd like in an additive engineer. And I said to myself, man, if I were a young guy, I'd be intimidated by that kind of list. Should people be applying for these jobs even if they don't meet all the requirements, if they think they have something to offer in additive?
Absolutely. We certainly hope so. And this is really, we have other openings that are much more generic. We have general design engineering positions that I don't know those numbers off the top of my head, but if you look at our website, there are a number of jobs across the country. This one just happens to be in the Puget Sound region of Washington State, but there are a number of jobs across the country for all different types of engineers, and some of them probably reference additive in some places. In this case, we created an opening where we wanted specifically to try to recruit some folks with some experience to help build on our capabilities as well. But certainly someone with some just general design experience or even a new hire graduate, we would encourage them to apply.
Good.
Can I add something to that?
Yeah, go ahead.
Yeah, so I think one of the challenges that is faced by candidates who see a job spec like this and think, well, I can do some of that, but not all of it. They're perhaps sometimes off from applying because of that. But at the same time, I don't think job descriptions that are put out there by organizations are really that creative. And they're not always that engaging when you consider that this is a really hot industry and organizations are competing for talent. At the same time, I don't think that human resource departments are really that well educated in understanding what a good candidate looks like and being able to identify that. And for the candidate who maybe doesn't tick all of the boxes, they get screened out before they're even given to the hiring manager to review. So I think that with such a high growth industry like this, organizations need to think very differently about their hiring. Actually, I think rather than trying to recruit sort of square pegs for square holes, people should just be trying to recruit great talent and thinking, okay, what skills and experience does this individual have and how can I use it? rather than I've got a job and I want these skills and experience.
Or to put it a slightly different way, instead of trying to recruit squares or circles, that what they should be doing is looking for putty that will fill anything.
Exactly.
Just squish it. Yeah, people who are flexible and get it. So, I do want to get back to one other question for Tim. Tim?
Yep.
You know, I've heard several people say that academia has not yet caught up with industry's needs for additive engineers, which is why they get paid a premium when companies can find them. And of course, that's why ASME is launching the metal additive manufacturing course this fall. I wanted to make sure we get one plug in for the course. So Tim, why don't you tell us what's going to be in it and who's it for?
Thanks, Alan. Sure. Actually, I wanted to make a quick comment on this the last discussion point there. I think one of the interesting things I've actually seen sort of in the discussions, some studies in psychology now, that with job descriptions like this, some interesting gender differences based on the job description. And so what I saw or heard recently in one study was that men are more likely to apply for jobs even if they don't check off all the boxes, whereas women actually, if they don't meet all of the criteria, actually will have much less likelihood that they will apply to the job. So I was just thinking as in this case, if we've got this long laundry list of skills and knowledge and materials and everything, inherently are we going to bias more men applying for those jobs versus others? So it could be interesting to both the way I think reframing how we create these job descriptions, because right now there is a broad set we need. I tend to recruit students that are good and passionate students, not whether they necessarily have the exact right skill sets for a project now. So it is my mentality and approach for sort of finding good talent has certainly shifted in additive manufacturing. If I can find a freshman or sophomore who's excited about additive and wants to learn, then I'm going to find a way to engage him or her in a project and then teach them what they don't know versus trying to find exactly the 16 different things that I specifically need. So just thought that was an interesting aha or light bulb that went off there on the previous discussion. So,
Good. So I did want to get you back though and mention who is the ASME's course for and what's going to be in it.
Absolutely.
And will they have the equivalent knowledge of a PhD in material science at the end?
No, that's not our goal, certainly. And I think that's part of what we're trying to address with this course here is the traditional models, just like the traditional recruiting model for hiring, the traditional model for learning is changing and is disrupting what we're used to seeing and doing. And so I think the opportunities now for on-demand, just-in-time, sort of focused learning around a particular topic is certainly as these technologies, additive, robotics, AI, big data, these Industry 4.0 technologies, they're evolving so quickly that the thought of somebody coming back for 4 years to get a PhD or even 2 years to get a master's is not enough. And so we're putting together, we specifically sort of looked at the whole space around additive, the whole ecosystem, hardware, software, materials, process, design, and then we specifically pinpointed from the design perspective, and particularly metals, let's really hone in on, focus in on that, because I think, end of the day, if you can't create a good value proposition around your design, then you're going to struggle with trying to make a case to your boss or getting the part to fly on an airplane or whatever the case may be. And so really focusing in on metals, powder bed, and sort of those three use cases, the replicate, adapt, and optimize. We sort of walk the user through all three of those and help them understand what are the design challenges and the design trade-offs and decisions that you need to make, because the sort of the trade-offs you're used to making, some of those aren't there anymore, and they're new trade-offs now that you as a designer may not think about. You don't just hand your CAD model over to a manufacturer anymore and say, make this. I mean, you can, but the likelihood of you getting back what you wanted is with additive can be extremely highly variable there, depending on who you're working with. So understanding from a design perspective what are the implications around build orientation, material choices, overhang, support structures. What does that do to post-processing and heat treatment and support removal? Are you going to get the right material properties? We certainly touch on all those things to help give you a good sense. We're targeting sort of an intermediate level, so not necessarily a novice, but not necessarily the expert either. The intermediate folk that's trying to get up to speed and help his or her team or boss figure out, what can I really do with additive? How do I help, separate the hype from the reality and help start moving my company forward, be it in a Boeing or a GM or GE or others that are out there.
Excellent. And also moving their career forward. Well, I'm afraid we've run out of time. And so, first of all, that was a really great conversation. And I think I know something about the topic, and I learned a lot. So thank you very much, our presenters, Nick Pierce, Niall Miyamoto, and Tim Simpson. If you'd like to learn more about ASME's metal additive manufacturing course, we'll be contacting you via email when the course goes live. And if you'd like to apply for some of those jobs at Boeing or get a copy of Nick's outstanding survey on jobs in this field and the types of salaries attached with them, we've got a link right here. And we've also got a link for Penn State if you'd like to learn more about the program there. Finally, thank you all for joining us today, and thank you for all your great questions. This is Alan Brown signing off.